Working with functions and their inverses is a little bit like going around in circles. Let's see what we mean by that. If we start with x, we put it into f, and we get some y value. And so we know that f is a function if each x value that we put in produces at the most only one y value. If we take a y value and put it into f inverse, we should get back the original x. And in fact, f inverse is a function if each of these y values will produce at the most one x value at a time. If this is the case, then f is 1 to 1. Now if f inverse is not a function, meaning that at least one y value that we can put into f inverse produces more than one x value, then we know that f is not 1 to 1. And we'll see what impact that has on inverses here in a moment. Okay, so we have x going through f producing y, and then y going backward through f inverse producing our original x. If we write y as f of x, we get this process that you see over here to the right. X goes through f to produce f of x goes through f inverse to produce x. So basically the output of f in purple is going directly into the input of f inverse. We start with x, we do something to it with f, we undo that same thing with f inverse, and we should get back our original x. So going in the forward direction, we can write it this way, and we should be able to go the opposite direction as well. If x is fed into f inverse, that should produce a y value, which is actually the output of our original f function, and going backward through the function should give us our original x. All right, so let's take a look and see how this relates to function compositions. Here's the diagram that we were just discussing on the previous slide. We take a value of x, we do something to it with f, then we undo that exact thing with f inverse, and that should give us back our starting point. If we think about this as a composition, what we're doing is plugging x into f in purple, and then plugging f into f inverse in green, and that gives us back our original x. So where it says test for inverse on the screen, that composition is one of the tests that we do to determine if two functions are inverses. The other test we have to do is going the other direction. We can take x and undo some operation that f is going to redo and get us right back where we started. So the way that this looks with a composition is x plugs into f inverse in green, and then that whole thing plugs into f in purple, and that should give us back x as well. Now, if f and g are inverses of each other, and f is 1 to 1, meaning g is a function, then f of g is going to be equal to g of f, and that's going to be equal to x. In other words, we should be able to take a function and plug it into its inverse and get x that we started with, and we should be able to take an inverse and plug it into the function and get back what we started with. Now the reason we have to do both tests is because if f is not 1 to 1, then we're possibly going to get more than one value of g for some value of x that we plug in. And so we'll be able to use that fact to determine whether or not we really have inverses of 1 to 1 functions or not. So let's take a look at a couple of examples to see how that works. We're going to start with a 1 to 1 function. And a typical 1 to 1 function is a straight line. And so here we have f of x equals 3x plus 5. If we do our inverse operation on that to write the inverse expression, we're going to get f inverse equals x minus 5 over 3. Now f is a straight line, and we know that all lines that are not vertical or horizontal are 1 to 1 functions because they pass both the vertical and horizontal line tests. Okay, so let's start with the first direction. We're going to take x, plug it into f inverse, and then plug that into f. So basically our 3x plus 5 function becomes 3 times x minus 5 over 3 plus 5, because what's in the parentheses there is f inverse. Now the 3 slope of the function f is going to cancel with the 3 in the denominator of f inverse and leave us with x minus 5. And then we're still adding 5 to it. So the negative 5 and the plus 5 end up being 0, and we get just x. So when we compose a function and its inverse and we get just x, we know that that has proven that that's an inverse in that direction. Let's go the other direction here. We're going to take f in purple and plug it into f inverse in green. So we take x minus 5 rather over 3, and we replace x with f, 3x plus 5. The plus 5 and the minus 5 are going to equal 0, leaving us with 3x over 3. And then the 3's cancel, giving us just x. So in both cases, f of f inverse and f inverse of f, we got x. Only one value, okay, only one expression. So we plugged in x, we got back x, going both directions. That means that these functions are inverses of each other. All right, let's look at an example now that's going to use a non-one-to-one function. And a simple, familiar non-one-to-one function is x squared. So f of x equals x squared, and we know that the inverse operation of squaring is square root. F inverse is a square root function. So f is a parabola, and we know that it's a function because it passes the vertical line test, but it's not one-to-one because it fails the horizontal line test. All right, so let's plug f inverse into f. We're going to basically be squaring the square root. So we know that this is always going to give us back whatever we have inside the square root. And so f of f inverse gives us x, which is what we want. So far our test for inverse is passing. Now we're going to test it the other direction. We're going to plug f into f inverse. This means we're going to take x squared and plug it into the square root function. Problem here is that the square root function can give us both a positive and a negative answer. So for example, if I have square root of 9, that can be 3 or it can be negative 3 because 3 squared is 9, but also negative 3 quantity squared is equal to 9. So f inverse plugged into f gave us just x, which is good, but f plugged into f inverse gave us x, and it also gave us negative x, which is not good. So f inverse has two possible output values for the single input value, and f inverse is not a function, therefore f is not one-to-one. Now in terms of taking inverses, we can say that the square root of x is an inverse of x squared, but not the only inverse, because we're going to get positive and negative answers going in the other direction.